There is something invisible, something massive, something that holds our galaxy together, yet we cannot see it, touch it, or detect it with any conventional instrument. Right now, as you watch this, dark matter is passing through you, millions of particles perhaps, streaming through your body, the walls of your home, the Earth itself. They interact with nothing. They acknowledge nothing. They are ghosts in the cosmic machine. Here's what should terrify you. Everything we can see in the universe, every star, every planet, every galaxy, every atom in your body represents less than 5% of what actually exists. The rest? Hidden, unknown, fundamentally different from anything we understand. For nearly a century, scientists have pursued this phantom substance. They've built detectors deep underground, launched telescopes into space, and constructed mathematical models of impossible elegance. What they've discovered doesn't comfort us, it challenges the very foundation of physics itself. What if the universe we see is just the foam on an ocean we cannot fathom? Today, we journey through evidence that challenges everything we thought we knew about reality. Prepare yourselves. We begin.
The year was 1933. Mount Wilson Observatory, California. A Swiss astronomer named Fritz Zwicky aimed his telescope at the Coma Cluster, a collection of over 1,000 galaxies located 320 million light-years from Earth. What Zwicky discovered would haunt physics for the next 90 years. He measured how fast these galaxies moved within the cluster. The velocities were staggering, thousands of kilometers per second. He then calculated the mass of all visible matter in the cluster based on the light from stars and gas. When he applied Newton's laws of gravity, something impossible emerged from the mathematics. The galaxies were moving too fast. Think of it this way. Imagine spinning a rock on a string. The faster you spin it, the more tension you need in the string to keep the rock from flying away. The Coma Cluster was spinning its galaxies so fast they should have been flung into the void billions of years ago. Yet there they remained, bound together. Zwicky calculated that the cluster needed roughly 400 times more mass than he could see to hold itself together. 400 times. He called this missing mass dunkle materia, dark matter. The astronomical community dismissed him. Zwicky had a reputation for difficult personality and radical ideas. His colleagues assumed he'd made an error. Perhaps his measurements were wrong. Perhaps gravity worked differently at cosmic scales. Perhaps the galaxies weren't actually bound together at all. For 40 years, dark matter remained a curiosity, a footnote in observational astronomy. Then, in the 1970s, a young astronomer named Vera Rubin changed everything. Rubin studied spiral galaxies, magnificent pinwheels of stars spinning in the cosmic dark. She focused on their rotation curves, measuring how fast stars orbit at different distances from the galactic center. The predictions were clear. Stars near the center should orbit quickly. Those at the edge should orbit slowly, just like planets in our solar system. Mercury races around the sun, distant Neptune crawls. But that's not what Rubin found. Galaxy after galaxy showed the same impossible pattern. Stars at the edge moved just as fast as stars near the center, sometimes faster. The rotation curves were flat, extending far beyond the visible disk of stars. The implications were immediate and disturbing. Either Newton's laws of gravity, tested for 3 centuries and confirmed in countless experiments, were fundamentally wrong, or galaxies contained enormous amounts of invisible mass. Rubin's work proved Zwicky wasn't mistaken. The phantom was real. But this represents just one piece of a much larger puzzle, because what scientists discovered next would reveal that dark matter doesn't just surround galaxies, it permeates the entire cosmic web, shaping the structure of reality itself. But the evidence forces us to confront an uncomfortable possibility. We live in a universe dominated by something we cannot comprehend.
The first truly undeniable proof came from 400 million light-years away, in a cosmic collision of such violence it defies comprehension: the Bullet Cluster. Two galaxy clusters, each containing hundreds of galaxies, had smashed together at millions of miles per hour. When scientists examined the aftermath using multiple telescopes, they saw something extraordinary. The visible matter, hot gas glowing in X-rays, had collided and slowed down, piling up at the collision site like cars in a highway accident. But gravitational lensing measurements revealed something else. The mass, the majority of the mass, had passed straight through. Think about what this means. The dark matter in each cluster felt no friction, no resistance. It ghosted through the collision as if the other cluster didn't exist. Today, the mass sits separated from the normal matter by 8 million trillion miles. This single observation destroyed the primary alternative to dark matter. Modified gravity theories predicted that mass and light should always align. The Bullet Cluster showed they could separate. Dark matter wasn't a mathematical trick or misunderstood gravity. It was real, physical, just invisible. But this represents just one piece of a much larger puzzle.
In 2013, the European Space Agency's Planck satellite mapped the cosmic microwave background radiation, the afterglow of the Big Bang itself. The measurements were precise to a millionth of a degree. What emerged was a baby picture of the universe, taken when it was just 380,000 years old. The patterns in that ancient light revealed the exact recipe of the universe: 4.9% ordinary matter, 26.8% dark matter, the rest, dark energy. These weren't estimates, they were measurements, precise to incredible accuracy. The universe had stamped its composition into the oldest light in existence. The evidence extends beyond individual galaxies into the realm of cosmic structure itself. Computer simulations running on the world's most powerful supercomputers have recreated the evolution of the universe. When you include dark matter, these simulations produce something remarkable. They create a cosmic web nearly identical to what we observe through our telescopes. Galaxies cluster along filaments. Vast voids open between them. The large-scale structure matches reality with unsettling precision. Remove dark matter from the simulation, and everything falls apart. Galaxies don't form. The cosmic web doesn't emerge. The universe becomes unrecognizable. Here's a specific finding that should haunt you. In 2018, astronomers discovered NGC 1052-DF2, a galaxy approximately the size of the Milky Way but containing almost no dark matter. This ultra-diffuse galaxy moves through space at velocities perfectly predicted by its visible matter alone. Why does this matter? Because it proves dark matter and ordinary matter can separate. Dark matter isn't just a property of space or a modification of gravity. It's a substance, something physical that can exist or not exist in different locations. Scientists have discovered similar dark matter deficient galaxies since then. NGC 1052-DF4, AGC 114905. Each one reinforces the same conclusion: dark matter is real, separate, and governed by rules we don't yet understand. The most remarkable discovery involves gravitational lensing on a cosmic scale. When light from distant galaxies passes near massive objects, gravity bends that light, creating distorted images, Einstein rings, arcs, multiple images of the same galaxy. By mapping these distortions across the sky, scientists can create maps of mass distribution, not what we see, but what actually exists. These maps reveal something spectacular. massive halos of dark matter surrounding every galaxy. The Milky Way sits inside a roughly spherical halo extending 10 times farther than the visible disk. This halo contains perhaps 1 trillion solar masses of dark matter. We are swimming in it, right now. The average density in our solar system is estimated at approximately 0.3 protons worth of dark matter per cubic centimeter. It doesn't sound like much, but integrated across the galaxy, it dominates everything. In 2020, researchers analyzing data from the Gaia satellite discovered something extraordinary about stellar streams, rivers of stars torn from ancient globular clusters by the Milky Way's gravity. The way these streams curve and twist as they orbit reveals the shape of our galaxy's dark matter halo with unprecedented precision. The halo isn't perfectly smooth. It has structure, lumps, smaller halos that have merged into ours over billions of years. Each irregularity tells a story of cosmic collisions and mergers stretching back to the universe's infancy. But here's where it gets strange. In 2021, researchers discovered that the rotation curves of galaxies show a remarkable consistency across cosmic time. Galaxies observed in the early universe, when they were just forming, already showed flat rotation curves. Dark matter halos existed from the beginning, perhaps even before the galaxies themselves. This suggests dark matter didn't just passively fill space, it actively shaped structure formation. Normal matter, atoms, hydrogen, all the stuff we're made of, fell into gravitational wells created by dark matter. Galaxies formed where dark matter allowed them to form. We are not the primary constituent of the universe. We are secondary, a consequence, structure that condensed in scaffolding built by something else entirely.